Hello and welcome back, and in this video we're going to continue with the test review. We're going to start with problem number 8 on your review, which is solve problems using linear and quadratic models. So we've downloaded the problems that were given on the review here. It says we have two different companies that have long distance phone providers. One charges a monthly fee of $7 plus 6 cents per minute, and the other one does not have a monthly fee but charges 8 cents per minute. It says find a linear function related cost to the total minutes for each company, so let's do that. We have A and we have B. So cost here is going to be your minutes, how many minutes you're charging. So on the first one you're charging 6 cents a minute, so it's 0.06 for every minute. And in B you're charging 0.08 per minute. And then if there's a monthly fee, we need to add that on there. A has a monthly fee of $7, so you'd add 7 to that. B does not have a monthly fee, so we could add 0, but we don't need to add anything. These are our two functions for cost for part A. It says determine the number of minutes for each bill company A will equal company B. So what we would do is we would take these two linear equations and we would set them equal to each other. Costs are being equal, we'd say 0.08x equals 0.06x plus 7. We'd subtract this x from both sides. And we get 0.02x equals 7. We would divide. Let's do the product. Let's multiply by 100 first. I don't like to deal with decimals, so if we multiply by 100, we get 2x equals 700. Now it's easier for me to divide. So that's 350 minutes. So they should be the same at 350 minutes. Okay, over what interval do the minutes of bill A of company B be less than company A? So to start off with, this one should cost more because it has a $7 fee. But since they're charging less, when they reach 350 minutes, they're the same. And then B will probably cost more because it overtakes that $7 fee. So what we're going to hear on part C is just asking us what interval of X will the bill from company B be less than bill from company A? Well, B should be less to start with because it doesn't have a fixed fee. So that would be, for letter C, that would be X would be less than or equal less than 350 minutes for that interval. Now you could write it as 0 to 350 as your interval notation, or you could use the inequality notation. All right, part 2 is a problem that was similar to those given on the focus problem. This is very similar to the focus problem. I think maybe the only difference here would be we have a different number for the total number of fencing. So we're enclosing a rectangular field. We divide it into two plots parallel to one another. It says find the largest area. So if we do that, we allow this side to be X and these sides to be Y. Basically your area is going to be X times Y. And you have 1,000 feet of fencing, so that's going to be 1,000 or 10,000, sorry, 10,000 equals 2x and 3y. So if we're going to figure out x or y here, and then we're going to substitute in here and write one equation so that we can find its largest area. So this is going to be a quadratic because it has two variables and they're both related to x or y. They're single power variables. Multiplied together is going to be a quadratic. Alright, so let's do Let's solve this. It'd be easier if I solve this for y, or I'm sorry, solve this for x, because I can divide 10,000 by 2 a little easier than I can to divide by 3. So we're going to write 2x equals 10,000 minus 3y. And then I'm going to divide by 2. So half of 10,000 is 5,000. And half of 3 is 3 halves. We don't have, or you can write 1.5 if you'd like. Alright, now I'm going to substitute that back in here for my y, or for my x. So I'm going to have 5,000 minus 3 halves x, or 3 halves y times y. So my area is going to be 5,000 y minus 3 halves y squared. And if I wrote that in standard form, it'd be negative 3 halves y squared plus 5,000 y. Now, since it's a quadratic, it has a maximum point, and its maximum point is at x equals negative b over 2a. So negative b over 2a is where the maximum or minimum. In this case, it's a maximum because of this. This term tells me it's a maximum because it goes down, because it's negative y squared. And now, I should have used y here, not x. So the y value here is minus b over 2a, because we kept the y's instead of x's. Alright, so in this case, our y value that's going to give us a maximum is going to be negative 5,000 over 2 times negative 3 halves. Now this is going to reduce out, so we're going to get y equals negative 5,000 over negative 3. So our answer to the maximum value is 5,000 divided by 3. So y is equal to 5,000 divided by 3. Okay, so in this case, that's in feet, I believe. Meters. So that's this distance along this side. Now, 5,000 divided by 3, I think, is like 1666 2/3. Let's just double check that with the calculator. $5,000 divided by 3. Yep, 1666 2/3. So 1666 2/3 meters is y. Alright, and if we need to find the answer here, it says the area to be enclosed. So we need to plug that back in right here to figure out what the answer is for the area, maximum area. So we would do that using a calculator, of course. So negative 3 halves, 3 halves times, in this case I have the answer right here, so I'm going to use my answer button here, second answer, so I don't have to type it in, squared, and then plus 5,000 times that, plus 5,000 times the answer. So, oops, second answer. Okay, so I'm using this number up here because I have it right now as that answer, and I'm just going to plug it into the area formula here. So that's giving me an answer of 416. Wait, it's 4,166,666.6. So 4,166,666 point and 2/3 basically meters squared is our area. Alright, so that's the solution there. And we can verify using the graphing calculator if we wanted to graph it and figure out if that's the maximum area. We could set this up the same way, just plot it here. Once we have the thing, we could just put in the equation which is this, and we could graph it and figure out if that's the same equation or the same maximum point. We just have to make sure our window could see these values. If we want to verify, we make sure our window goes up to 16,000. So we'd have to make sure that this went up to 20,000 maybe. And I would want to count by more than 1. Okay, and then this one, we'd say it's 4 million, so it'd have to go up to at least 5 million. We count by maybe. Okay, which graph, you should see the maximum point right here, and we should be able to find that, and hopefully it's the same value here. So I can calculate maximum. Oops. Okay. All right, I need to reset my window here. Okay, so here's my maximum. So I didn't have the window set very well. Okay. Okay, now I see the maximum. It's a little clearer. This is what happens sometimes. You have to take. Okay, left bound. I didn't get the left bound. Okay, we got to be left of the maximum. Enter. Now right bound. Let's drop down a bit. Enter, enter. Okay, so it calculates about the same number right here on the maximum value, and here's our area right there. It's the same value. So we use the graphing calculator to verify that. Okay, we'll move on to the next problem here.